Hi there, this is Tim from Second State. Today I'm going to show you a rule-based smart contract example. If you head on over to docs.secondstate.io, you'll see down on the left-hand menu here the rule-based smart contract link. And this page will walk us through an example of making a purchase and the customer getting a 5% rebate up to $100 for every purchase that is $100 or more. So if we have a look at this first paragraph, we'll see the source code for this demonstration. So we'll click on that and you'll see that we have HTML and JavaScript and also smart contract source code. Now the tool that we'll be using for this demonstration is the Second State build tool. For those of you that haven't seen this before, I'll just give you a very quick introduction to it. So we have a contract tab, and this is where the smart contract source code goes. We also have this DApp tab, and this is where the HTML, the CSS, and the JavaScript lives. If we click Run, then what we see on the right-hand side of the screen is the what the end user would see if they were using your DApp. So it's essentially the HTML output, which is fed by the data from the smart contract. So what we might do is go ahead and actually grab the HTML, JavaScript, and also the smart contract source code and put that into the IDE. So HTML tab here, and go to the JavaScript tab. And it's always best to just click the raw button there and just take this raw data so that we're sure that there's no formatting or anything coming through with it. Okay, and then back over to the contract tab and we'll go and grab the smart contract source code. Okay, now if you haven't seen this before, this is pretty amazing. What we have here is the contract code. We click the compile button, that compiles the code. It gives us both the ABI and the bytecode. We then, so I'll just show you quickly, there's a name required here. So if we have a look at the constructor in this smart contract code, in order to deploy this on the chain, we need to give it a name. So I'll just put in there Tim, and if we click deploy to chain, it says that a transaction's been sent. There's the transaction ID, and already that's succeeded and has been deployed. Now, the reason why that's so fast is if we have a look down in this providers link here, you'll see that this environment is actually running on a special second state development chain, and this has a 1 second block time. So it's very fast and an excellent environment for rapid development of your decentralized application and your smart contract. Okay, so that's basically all we have to do on this end. If we go over to the DApp tab, we've already loaded in that HTML and JavaScript for the demonstration. If we click Run, what we see over on the right-hand side is, as I mentioned before, what your end user would see. Now, you'll notice that this is a record for John Doe, and this is because in this particular example, we're using a smart contract address, and it's just being statically typed in here. So just to show you the power and the flexibility of this tool, let's do something interesting. We'll go back to the contract tab and see where it's given us this transaction hash here. You'll also see that once it's resolved, it's actually given us the address as well. So if we copy that, and we'll go over to just an ordinary REST client, because all of the activity on the second state development chain is actually loaded into what we call our smart contract search engine. So I'll click send, and what that'll do is it'll retrieve our Tim person that we've just created a couple of seconds ago. So if I take this contract address now, and we'll put this into the JavaScript over on the build tool. So I'm just going to replace this statically typed address with our newly deployed address. And if I hit run, we see here record for Tim with no purchases and no rebates as yet, which makes sense because this is a brand new contract. So this just shows you the power of this tool. Now what we might do is just use this particular Tim contract. Okay, so we're going to add a purchase, and we'll put in a purchase for, say, $99 and click OK. So we have a purchase for $99, so our total purchases is $99, and the rebate amount to date is 0. So we'll go ahead and click add again and maybe put in one for $101. Okay, now as you can see, we have purchases now which total $200, and the rebate tally is now $5. So this is using the rule engine. Let's go back and have a look at that. Okay. If we're looking at this smart contract source code, you'll see that the top half is fairly straightforward. We have this contract person, we have a few data structures in this and a few variables. So this is all fairly vanilla. Down the bottom here though, you'll see the rule component. So this is the rule name. This when block is essentially a filter. And inside the filter here, you'll see this letter P. So we could call this a fact, and we have a type here, which is of type purchase. So if we see we have a struct up here called purchase. So this fact down here is of type purchase. And if we go a little bit over to the right, what's in these parentheses is essentially constraints. Now, any of the constraints that are met with these types will be caught in, let's call it a filter. And then the next block, which is this then block, essentially executes the actions on anything which has been included in this previous filter here. Now, there's a great explanation of all of this. If you scroll down on the documentation here, you'll see that there is a LIDE rules documentation link. And if you go over to that documentation, which is lidi.readthedocs.io, you'll see some really great examples, not only of the syntax, how the rules engine works in the working memory and so forth, but you'll see some actual examples of like insurance and like here's one, insurance rating, insurance claims. So obviously there's a long history of the success of rules engines in financial and enterprise software, and Second State brings this forward. It's providing a formal rules engine which you can now use inside decentralized applications and smart contracts. So feel free to check out this documentation as well as the LIDE documentation. If you have any questions, please reach out to us.